Hi everyone. So today we will see one of the most basic concept of the analog IC design. So today we will start with the frequency response of the one of the stages of the amplifier. Response of response of common source stage. Common source stage. So you always you already know that what is the common source stage. So common source stage is the stage in which the input of the stage is given to the gate of the MOSFET here input, and output is taken from the drain of the amplifier or drain of the MOSFET. So this is the point the input is given, this is the point where the output is taken, and this is the R load, some load resistance is there. Okay, so first we need to bias our MOSFET at the operating point. So first we need to bias it at a operating point. So let's say the amplifier is in negative feedback, so by itself it will bias such that the MOSFET will be in saturation. Now we need to find out the frequency response of the MOSFET. So we know that there will be some gap, there will be some gap at this node, at this node, and the input is coming from the input is coming from the previous stage, so previous stage can also have some of the resistance. Now we will find out what is the small signal diagram of this circuit. So small signal, we can say we are giving some of the input input here. So we are giving the input here, which is I, and this is the R in input resistance. Now we are also having the CGS of the MOSFET, CGS of the MOSFET. Now the voltage at here is corresponding to this node voltage. Now it will see one cap, which is the CGT, which is having the interaction from input to output directly, one of the path, and the other part is the other path is through the MOSFET. So this is the MOSFET. So we can find out this is, let's say, GM, some V voltage at this node. So this current will be GM times V. Okay. Now we will also have some of the R naught, which is the output impedance of the MOSFET. Okay, now we are also having some of the load resistance RL, and we also have some cap. Okay, this cap is like this node equivalent cap to the ground. Okay, now this is the equivalent circuit of the common source stage, which is common source stage. So we can simplify this stage, this like R in. Now we are having, this is the CGS, and we are having the CGD, and we are having 6 GMV, and we are also having some of the RL, and here we can say CL, and we find that RL is the equivalent resistance of R naught parallel RL, and CL is the equivalent cap at the output to the ground. Okay, now this is my V in voltage. Now this is the equivalent circuit. We need to find out the V out and V in. So our basic plan is to find out V out divided by V in the frequency domain. So what is this voltage? Okay, so this is the voltage V, because this node voltage is having V. So now we will write the equations for this. So uh, we will write the equations. So first equation I will write as the KVL from this node. So the current which is flowing through this, that will equal to this plus this, and okay, and the other equation I will apply, like this current will be equal to this current plus this current. Okay, so this is the two equations. So first equations I will write V in minus V, okay, divided by R in, that will be equal to your V times SCGS, this current, and the other current will be V minus V out divided by multiply by SCGD, multiply by SCGD. So this is the one of the equation number one. And the second equation I will write V minus V out into SCGD is equals to GMV in GMV, like this current, plus the current which is flowing through this. So this current will be V out by RL 1 plus S CL RL. So this current is the this current will be the current which is flowing through both the RL and CL. So V out divided by the equivalent resistance of the RL and CL. That will be the that current. So if you solve the equation number two, then you will find that what is the your this V out divided by V. So that will be V out by V. So that will be your GM minus S CGD. Okay, GM minus S CGD, that is the coefficient of the V, that is this coefficient and this coefficient divided by coefficient of V out. The coefficient of V out will be, that will be SCGD plus coefficient through this 1 plus SCL RL divided by RL. That is the, so you will get GM minus SCGD times RL divided by 1 plus 1 plus S CLRL plus S CGD times RL. So you will find that your V out by V is equals to V out by V equals to minus GM minus S CGD times RL divided by 1 plus S RL CGD plus CL. Okay, this is the one of the equation. And similarly, if you find, uh, if you write the if you put the value of the V from this equation to this equation in the equation number one, then you will get uh, like you will get the term. I will like write directly, I will write that. So your uh, uh, the transfer function will be minus gm rl minus s cgd divided by 1 plus s. Okay, now uh, that will be equal to your r in cgs plus gm times r naught into cgd, that will be added to the cgs plus cgd times gm rl. Let's say a, you will get 1 plus a times here. So that is your equivalent coefficient of s, then s square times your cgs multiply cgd multiply r in multiply rl. That will be the coefficient of the s square terms. So by intuition you can find, you can check this transfer function and you can find out what is the zero and pole of the common source stage. So 0 here, 0 is this coefficient. If you put it, put the numerator equal to 0, then you will get the frequency at which gm divided by cgd, this is the frequency at which there will be 0. And how the 0 will form? The 0 will form through the stage, like this stage. So there are two paths from input to output. One is from like this, and other one is from like this to this. So this is the V voltage. This V voltage either can flow through this, or this voltage V voltage is the this is the voltage V, and this is my the current voltage control current source. So this V will go to this, and this current will also can affect the V out. So there are two paths from in this point to this point. One is this path, and one other one is this path. So when these both path current will equal, so let's say the current through both paths are equal, and the voltage at that node will be 0. So we will get some voltage V. So V times SCGT, that will equal to Gm times V. So V2 we cancel, and the frequency at which this occurs, that is equals to CGD. So at this frequency, all the current which is flowing from here to here, that will go here to here. So you will get a constant voltage, and here the 0 will occur, and you will get some constant voltage. So this is the zero frequency, and from here I can find out what is the pole frequency. So the pole frequency, uh, I can, so this expression is almost so this is approximate expression. So the pole frequency is coming from, so uh, here there are three uh, energy storing elements are there. One is this one, other one is this one, and other one is the load cap. But but you will get only two poles, because one of if you write down the KVL equation through this loop, then one of the voltage will be dependent voltage, and two, you can say this is V1, this is V2, then the V3 I can easily find out through the KVL equation through the loop, because there are no voltage source involved. So I can write down the V3 in the terms of V1 and V2. So this voltage is independent. So so the input pole, the pole will come through, like there is one R and one CGS is there, and this is one CGD is there. So how you can find out the pole? So the pole is, like usually we see, the pole is the 1 upon tau 1 and tau 2. Let's say plus tau n, tau 3. Let's say many time constants are there in the circuit. So the equivalent pole of the circuit will be 1 upon tau 1 plus tau 2 plus tau 3. So we need to find out how much is the gap we are seeing. So this tau 1 is the input side, input time constant, input gap time constant. This is output time constant. So similarly you can find out what are your tau 1, tau 2, tau 3, the time constant, and you from there you can find out the pole. So here you can see that the time constant, the equivalent time constant of this CGS will be this CGS. When you find out the equivalent time constant, you will see the equivalent cap will be CGS plus 1 plus GM times RL times CGD. That is the cap, because if you give some delta V here, you will get some minus A times delta V here. So from this node you will see, if you give delta V here, you will get minus A times delta V, and from where this minus A delta V came, that is coming from the gain stage of the common source. And okay, so this CGT we will get 1 plus A times. So this is my 1 plus A times CGD. This is the total cap which you see through input. and so your pole will be 1 upon r times r in times cgs plus 1 plus gmrl times cgd. So this is the input time constant, and similarly output time constant is also there. So let's say this is gmrl, gmv, and this is the rl. So from output also you can find out rl times cgd, that is your output time constant, and from there you can find out the pole. So this is the dominant pole, and you also know that there will be two poles in the transfer functions. So you will get two poles. So second pole also you can find out. Let's say from the dominant pole, let's say omega 1 is very more than omega d. So one of the pole is dominant pole, and other pole is very is, is lie at very high frequency, so that will be non-dominant pole. So let's say there are two poles in the system. So what we can do, so let's say there are two poles in the system, and both poles are left hand side. So we can write down the equation like this: 1 plus 1 upon s omega 1. So this is the equation, let's say. So if you solve this equation, this is the pole equation, or you can say the denominator is like this. So if you solve this equation, then you will get 1 plus omega 1 plus 1 by omega d, and plus s square omega 1 omega d. So let's say omega 1 is very higher than omega d, then 1 by omega 1 is very lesser than 1 by omega d. So here you will get that is almost equal to 1 plus s by omega d plus s square by omega 1 omega d. So this is the denominator of the equation, and from here you can also find out, or you can also compare this term with this term, and you can find out the omega dominant pole, and also the other non-dominant pole through this. So non-dominant pole will be uh, coefficient of non-dominant pole. So dominant pole is the inverse of the coefficient of S term. So this is the uh, inverse of the coefficient of S term. So from there you can find out, this is the uh, first pole, and the second pole will be, you can find out through this one. So coefficient of S square. So from here you can find out omega 1 times omega d is equals to 1 upon coefficient of s square. Coefficient of s square omega 1 is equals to 1 upon omega d into coefficient of s square. From here you can find out. Okay, thank you guys. These are the two poles and zeros of the common source stage. If you have any doubt, you can comment in the comment box, and thanks.